You have built an amazing notebook or script in Databricks. It works perfectly when you run it. But then what? Do you just run it again tomorrow? And the next day? What if it fails at 3 a.m.? That's where most people get stuck. And that's exactly what we are fixing today. I am going to walk you through the entire Databricks Jobs and Workflows system, not just the buttons, but the professional way to set it up so your data pipelines run reliably, scale automatically, and notify you when things go wrong. Manually clicking run is your data team's biggest bottleneck. Stop it. You will create a job once, and from that moment on, your team stops running code by hand. This is how you automate your entire data pipeline, from a single script to a complex, multi-step production system. Think of a job as your command center. You define everything here, schedule it, and let Databricks execute it flawlessly, on time, every time. But if a job is your command center, a workflow is your entire battle plan. It orchestrates multiple jobs into a coordinated sequence. You define the entire campaign, which job runs first, which depends on another's success, and Databricks executes the master strategy. This is how you transform isolated tasks into a cohesive, automated production pipeline. That's the real power. Do not build a tower of jobs. That's missing the point. The real shift is from executing tasks to designing processes. A job performs a duty. A workflow models a business outcome with success, failure, and timing baked into its blueprint. Stop thinking in steps and start engineering results. That's the evolution from a tool operator to a pipeline architect. Stop clicking run. Your data pipelines are dangerously fragile. So you are staring at the Create Job button. It is deceptively simple. But right here is where your entire orchestration philosophy is decided: manual task versus automated system. You are not just launching a notebook, you are defining a production asset. This choice codifies reliability. Let's architect it, not just click it. That's just a location. The real engineering is in the environment. Do not just link a file, you are embedding a self-contained execution universe. The cluster specs, libraries, and parameters you attach here are the contract. This guarantees the task runs identically every time, eliminating "it works on my laptop" forever. This is production. Now, here's the critical choice. A shared, all-purpose cluster is noisy and unpredictable for production. You need isolation. A job cluster is born for this single task, with your exact specifications, and then vanishes. It's clean, dedicated, and cost-effective. This isn't just a config switch, it's your first commitment to reliability. Stop clicking run. Your Databricks workflows can manage themselves. Let's break the biggest misconception. You aren't stuck with the clusters on your interactive tabs. A dedicated job cluster spins up just for your task. It is a transient, purpose-built engine. When the code finishes, the cluster terminates. You stop paying. This isn't just efficient, it is how professional automation should run. Now, here's the secret: never match the driver and worker types unless you have to. For most data tasks, you need a robust driver to manage the workflow, but your workers can be smaller and cheaper. Mismatch them intelligently, optimize the driver for orchestration and workers for parallel computation. This single choice slashes your cloud bill. Now, let's crush a massive hidden cost. You think autoscaling is about adding machines? Wrong. It is about aggressive, intelligent scale down. Set your idle timeout brutally low to 2 minutes. The cluster must shrink at the first sign of calm. This eliminates paying for ghost capacity and turns variable costs into a superpower. Stop clicking run. Start building pipelines that never break. But here's the warning, your business does not operate on a perfect daily clock. What about that new data feed arriving at 2:17 a.m.? Or the dependent job that must finish first? A simple cron schedule will fail you. We must graduate to production-grade triggers. This is about building a resilient, event-driven system, not just a timed task. So, here's your upgrade. Instead of blindly checking a folder every hour, you configure a trigger to listen for the object creation event itself. The Cloud Storage Service, S3 or ADLS, sends a direct signal to your Databricks job the moment the final file lands. Your workflow wakes up instantly, reacting to reality, not a guess. This is zero-waste execution. Now, let's lock it down. Go beyond the Schedule tab. Right in the Jobs Alert settings, you define exactly who gets a ping and when on flawless success, a catastrophic failure, or if a task just grinds past its timeout. This isn't just notification, it is a targeted distress signal. Your team stops watching logs and starts acting. Manual triggers are a career-limiting risk you cannot afford. Manual triggers invite failure. It is not about if, but when. Your real power lies in chaining tasks into a resilient pipeline. A single job now handles your entire logic, run a notebook, feed its result to another, then automatically log everything. This is how you create self-healing, professional workflows that do not just run, they own the responsibility of success. Think of a relay race. A baton isn't passed until the first runner completes their leg. This is task dependency. You define the exact order, only after a notebook succeeds does the next task receive its output and begin. You are not just running code, you are orchestrating a precise, fault-tolerant sequence where success triggers the next move. Now, let's talk about the handoff itself. How do you actually pass data between tasks? You have two powerful options, passing lightweight parameters to control behavior or using a feature like the Lakeview cache to pass entire data frames. This is the magic that connects your isolated tasks into a true, integrated data pipeline. Stop clicking run. Let Databricks do the work for you. Think about it. That run just failed, but why? Do not get stuck guessing. The run's view is your control tower. You will instantly see every job, every schedule, and every last log. Spot a failure, drill straight into the detailed execution logs, and find the exact broken line of code. This is how you go from reactive firefighting to proactive control. But just seeing that red failed flag isn't enough. The real power is in the logs. You have to go deeper than the Spark UI. I'm talking about the driver log, the steeder, and the specific worker logs. This is where you will find the Python traceback or the Scala error that caused the entire cluster to stop. This is your definitive root cause. Now, everyone points you to the Spark UI for performance, but that's a surface-level dashboard. True debugging power isn't in charts, it's in the event timeline. See which tasks are actually blocking others and identify the single thread holding your entire workflow hostage. That's the real bottleneck. Charts show symptoms, the timeline reveals the disease. Manually refreshing data is a career-limiting move. Discover the hidden orchestrator. Do not just lock the workspace door. Control access to each job individually. Assign can manage or can run permissions to users and service principals. This creates fine-grained security, preventing accidental edits or unauthorized runs that could corrupt a pipeline or spike your cloud bill. This is precision control for your most critical workflows. Now, a job fails. The default retry fires immediately, hammering the same exhausted API or resource. That's chaos. Instead, implement a retry policy with exponential backoff. It waits longer between each attempt, giving the external service time to recover. This is the resilient pattern that handles real-world, transient failures without creating a cascading outage. Picture this, your central orchestrator runs in a secure, managed control plane, but its child jobs execute across different workspaces. You use service principals and Databricks secrets for each environment's authentication. This isolates blast radius, controls costs, and enforces governance. You are now engineering systems, not just running isolated scripts. Databricks jobs turn your one-off scripts into scheduled, monitored, and reliable data pipelines. Always consider job clusters for cost efficiency and use workflows to model task dependencies. Proper alerting and logging turn a black box job into a maintainable system. Try setting up a job for your most frequent notebook this week and see how much time it saves you.